Coming to 2.2, that is coupled circuits. I have some problems on coupled circuits. Question number 1, the question says obtain the dotted equivalent circuit for the figure shown below. Figure shown below. The question given is resistor on this. There is a coil, then a capacitor, again it is coiled, then say again a capacitor, then a coil, and this is connected to a voltage source. This is excited by a voltage source plus minus V of t. This is R. Now the current will flow in this direction, in this way, through this capacitor. Say this is C1, we will call this as inductor L1, this as inductor L2, this as capacitor C2, and this as inductor L3. The current will flow through this coil in this direction, then again it will flow through this in this direction. So as per the right hand thumb rule, if the current is flowing in this direction, the flux will be induced in the upward direction. So I am showing in the same diagram. Similarly, if the current is flowing in this direction, so the flux will induced in the downward direction, and in this case also the flux will be induced in the downward direction. So if you want to draw the equivalent circuit, then you have a resistor as given in the circuit, then L1 as an inductor, then C1 capacitor, L2 inductor, C2 capacitor, L3 inductor, and this is the supply voltage. So this is the equivalent circuit: R, L1, C1, L2, C2, L3. Now you need to put the dot, so the flux moving out will be the point for the dot. So this will be the dot for L1. For L2, the flux is leaving out, so here you will have dot, and for L3 it will have dot here. The direction of L2 and L3 have the same direction of the dot. So this is how you draw the equivalent circuit for the dotted equivalent circuit for the given diagram. Now for in question number 2 is given as, this is the first part of question number 1. Question number 2 is given, say over a conductor you have coil, say this is the diagram given. Current is entering, then in this direction, then in the below direction, and then out of the conductor. Now suppose say self is given, self mutual inductance and self inductance. Say self inductance is given as J2 in this case. For this it is given as J4. For this it is given as J7. That is between these two. Then between these two, this is for this coil, this is for this coil, this is for this coil. Between these two it is given as J5. Between these two it is given as J1, and between the first and the last it is given as J2. Now how we draw the equivalent of this? We have 1, 2, 3 inductors. So let us call this as L1, L2 and L3. So you have 3 inductors, L1, L2, L3. Value of these inductors you have J2, J4, J7. Now current is moving, current is flowing in the upward direction. So by right hand thumb rule you have flux to be in this direction. In this case it is flowing downwards, so the direction of the current will flux will be in this. Similarly for this the direction of flux will be in the direction. So current is the flux is leaving from this point, so here we will make dot. In this case it is moving out, so here we will make dot. In this case it is moving out from this side, so here we will make the dot. Now the mutual capacitance, the mutual inductance is given as J5 between these two, so we put arrow and write J5. Between this and this it is given as J1, and between first and the last it is given as J2. So this is how we make the diagram. So J2 is between the first and the last. Similarly here you have J2 between first and last. So this is how we make the equivalent circuit. You can see if I make it dark, this is between first and third, this is between first and second, and this is between second and third. So this is how you make the dotted equivalent circuit.